In this student challenge, you have two tasks to do. First one is you have to find out the radix of a given number if the number is given in the form of a string. And the second one is to check whether a given year is a leap year or not. So I will explain what you have to do. So just you have to follow this and write a program by yourself. So let us pick up the first task, finding the radix of a given number in the form of a string. So a number is given in the form of a string. So let us take an example. I will take an example that is string str. Okay, I will call it as number instead of str. And this is having 1010110. So obviously this is a binary number. So radix 2. Now the next is if the string is like I will take a number 1, 2, 3, 5 and 7. So if you see this number, the smallest digit I have taken is 1 and the largest digit I have taken is 7. So there is no digit beyond 7. So if you remember, the range of digits from 0 to 7 are octal number system. So radix 8. So if digits are in between 0 to 7, then we can say this is octal number system. This is octal. And the radix is 8. So this is binary number system and radix is 2. Now next, if I have a number A25B, so this is having digits between 0 to F. So this is hexadecimal. So if the digits are in between this range, then you have to say it is hexadecimal or radix is 16. So you can display anything that you like. So now you have to write a program. In a program, you have to read a string from the keyboard, and that string should be of these forms, right? So check if it is of this type. If it is so, then say it is binary. And if it is having the digits between 0 to 7, say it is octal. And if it is having digits 0 to 9 and also A to F, then you can say it is hexadecimal. Other than this, if it is not satisfying any one of these, then you can say number is invalid. Oh, I missed one thing. Sorry. Actually, one more number. 2, 5, 9, 6, 7, 8. Now this is decimal. This is decimal. So actually I missed decimal itself. So this is decimal number system. So if the digits are between 0 to 9, then you can say it's a decimal number system and the radix is 10. So 2, 8, 16 and 10. So you have to print all these. If the number is not among this, the given string is not among this, then it is an invalid number, you can say. So from the keyboard, you take a string and check whether it is satisfying this one, otherwise this one, or this one, or this one, any one of these. So you have to write 4 conditional statements. If, then else, then if, then else. So you have to write multiple conditional statements. Write on the program. If you are unable to do, you can continue watching the video. I will be showing the solution for this one. So pause the video and please write the program by yourself. That's good. So I guess you have done it. So if not, if you got any problem, then let us see the program. I will write on the program. So I have kept the part of a program ready. I have written some code. Import is there and a scanner I have created, declared a string with a name num, reference is num. Here I am giving a message, enter a number, then also reading a string using next line. Now once I get a string, I have to start checking whether it is a binary or octal or decimal. So in which order I should check? First of all, I should check whether it is binary or not. So in a number, how to check whether it is binary or not? Is it having only binary digits or not? You can use a regular expression. Matches, is it matching 0 or 1? And that should be for one or more time. It cannot be 0. If it is true, then I should print a message system.out.println. It's a binary and radix is 2. So this is for binary number. Else, then inside else, again I should check. If it is not a binary, then I should check a condition whether the number is matching a regular expression for octal number system. So the octal number system is from 0 to 7 and there should be one or more digits. If it is true, then we will print. So I will copy this one. Here we will write down octal number system and the radix is 8. So again, if it is not binary, it comes here and it checks for octal. If it is not octal, then again else. See, I am writing nested if. If, then else, then inside that again if. Then again I have to write down else and so on. So if you have to write nested if, always if is coming inside else, then we can write it like a else if ladder. This already I have explained you. I will remove this. Remove this bracket. Okay. And you can write if just beside that else. You don't have to give a gap, line gap. Okay. Else then bracket. So no need of this bracket now. I have removed this opening bracket, so I should remove this closing bracket also. Then this bracket belongs to whom? This bracket belongs to this if. So okay, let it be in next line. Now this is like a else if ladder. First of all, I am checking for binary. If it is not binary, if it is having digits other than 0 or 1, then there may be digits from 0 to 7. If not, then again I should write else if. So I will copy this one and paste it here. Now this should be from 0 to 9 and this is decimal and radix is 10. Now after this, one more else if, I will paste it. So here it is 0 to 9 as well as from A to F. A to F. Then this is hexadecimal. Okay, I'll just write hexa and radix is 16. Else I should say it is not a number. So I will print it. So that's it. This is the program. Let us run the program now. Program is running. I'll give the input as 100110. See, radix is 2. Again I will run it. Enter a number. Number is 12367. So this is radix 8. And see, if it is in between 0 to 7, it can be even decimal or hexadecimal also. But we are saying that this may be octal. Okay, this is the criteria we are checking. Okay, this may be octal because this is not having any digit above 7. Okay, so it is valid octal number. The next is 9765. I'll give a number. So this is decimal number. Yes, perfect. So is it a valid decimal number? Yes. A, B, 1, 2. So this is radix 16 and it cannot be less than 16. It cannot be decimal at all, right? Because this is having alphabets also. So this is the task. Hope you have done it by yourself. Alright, so just we are checking whether a number is a valid octal number or not, or hexadecimal or not. Okay, if you want, you can refine this task more. Like if this number is octal, then definitely it can be a decimal also, it can be a hexadecimal also. And if a number is a decimal, then it can be hexadecimal also. And if a number is binary, then it can be binary, octal, decimal, hexadecimal. It can be of any radix. But we are checking whether the digits that are used are within that radix or not. Alright. So that's all about this task. Now let us look at the next task. Now our next task is finding a given year is a leap year or not. In this task you have to take a year number, just year, not a complete date, just a year number, and find out whether it is a leap year or not. See, the purpose of doing this task is to learn how to write conditional statements. Alright. But in Java, you don't have to worry about what is a leap year and how to check it, whether it's a leap year or not. You don't have to worry about this. There are a lot of built-in methods available inside built-in classes. So you can use those classes and know whether a year is a leap year or not without knowing how to calculate leap year. But the purpose of doing it as a task here is to learn how to write conditional statements. So this is one of the complex topic. So let us study it. So for this, first of all, I will explain you what does it mean by a leap year. Okay. Then I will explain everything about it. Then you have to write down a program. Let us open a browser and search for what is leap year. So here in the browser, I have checked what is a leap year. So I got first link from Wikipedia. So let us go to Wikipedia. What does Wikipedia says? See, the calendar that we follow nowadays is a Gregorian calendar. It is called as a Gregorian calendar. It was introduced around some 1500 AD, some year. And before that, people used to follow Julian calendar. And Julian calendar was having some errors. So those errors were removed in Gregorian calendar. See, you may be knowing that Earth revolves around Sun, and to complete one complete round, it takes 365 plus days. 365 plus days it will take. So that was not counted properly in Julian calendar. So in Gregorian, he has removed that error. So the calendar name is given on the name of person who has introduced it. So I will show you the required part. See, in a year, there are 365 and 1/4 days. 365 and 1/4 days, right? So in decimal form, float point, it is 365.24. It is not 25. So let us assume it is 25. Okay, if it is 25 means 1/4. In every fourth year, we can count one extra day. So that's what we find usually. In every 4 years, February month will have 29 days. That is the reason. So if in a year, a February month is having 29 days, then it is called as leap year. So it means if a year number is divisible by 4, exactly divisible by 4, then it is a leap year. Yes, every fourth year is a leap year. Like suppose if you start from the beginning, fourth year is a leap year, 8th year is a leap year, 12th is a leap year. Yes, every fourth year is a leap year. But one more error is there. It's not exactly 0.245. It is not exactly 0.25. It is 0.24. And after that, it is 2.1. Or let us take it as 2.2. Okay. So what about this error? It is not exactly 25, 0.25. So for removing this error, for every 100th year, if a year is divisible by 100, we will say it is not a leap year. It is not a leap year. Right? Because we will be counting extra one day because it is not 25. But if a year is divisible by 400, then we say it is a leap year. So if you read on this page, you will find everything details here. So let us go back to our slide. There I will explain details about that one. See, if you read it, see, it should be divisible by 100. But if it is not divisible by 400, then it is not a leap year. If it is divisible by 100, then it should be divisible by 400 also. So let us come back. Suppose I have a year that is 2000, right? This 2000 is divisible by 4. It gets exactly divisible by 4. What does it mean by exactly divisible by 4? If a number is exactly divisible by 4, means it should leave a remainder 0 when it is divided by 4. So it will divide 4 into 500 is 2000. Remainder is 0. So if a number is exactly divisible by 4, then it is a leap year. Okay, so you have to write on the conditions like this. I will help you a little bit. So year you have to take input as a integer value. Then if a year mod 4 is equals to 0, then it is a leap year. Yes, it is a leap year. So else, so it is not a leap year. Wait. If a year is divisible by 4, then every year divisible by 4 is not a leap year. Is it? If it is divisible by 100, if it is exactly divisible by 100, then it is not a leap year. Else it is a leap year. If it is divisible by 4, then check if it is divisible by 100 also. If it is not divisible, else it's a leap year. If it is not divisible by 4, then it is not a leap year. Then wait, if it is divisible by 100, then check if it is divisible by 400 also. So if it is also divisible by 400, then yes, it is a leap year. Else it is not a leap year. So let us understand it once again. If a year is divisible by 4, then it may be a leap year. Otherwise, it is definitely not a leap year. If it is divisible by 4, then check that every year which is divisible by 100, we will skip it. We will not count it as a leap year. If it is not divisible, then we simply say yes, it is a leap year. Then we simply say yes, it is a leap year. If it is divisible by 100, then it should also be divisible by 400. So if yes, then we say it's a leap year, otherwise we say no, not a leap year. So these are little complex conditions. I have written the pseudocode here, so this is sufficient for you to write a complete program. If you want, you can frame it in a different way also, that's your choice. So this is how I have written the conditional statements. Now you write a program, take a year as a input from the keyboard as an integer type, then check all these conditions and display a leap year or not a leap year. I'll show you here. See, this 1600, 2000 and 2400 is a leap year, but whereas 1700, 1800 and 1900, these are not divisible by 400, so these are not leap years. So check these values by yourself. 17, 18, 19 are not leap years, right? See, 1700, 1800 and 1900 are not leap years, so your program should give no for these, right? So pause the video here and try the program by yourself, and if you want help, you can continue watching video. I will be writing the program and showing you. So in the same program, I have written a separate main method. The previous program I made it as a comment. So here I have a scanner. I am reading a year, okay, as an integer. Then till here I have written the code. If year mod 4 is equal to 400, then it may be a leap year. It's not necessary that it's a leap year. But if it is not divisible by 4, then definitely it's not a leap year. I will copy this statement because I need it. Then here. Then I have to check if a year is exactly divisible by 100. If it is exactly divisible by 100, then it may or may not be a leap year. We can't say. We can't say. If it is not divisible by 100, if it is not divisible by 100, then definitely it's a leap year. So I will paste it here. Yes, it's a leap year. So it's a leap year. Yes, if it is not divisible by 100. So I wrote it in the else part. If it is divisible by 100, then make sure that it is also exactly divisible by 400. Okay. Year mod 400 should be exactly equal to 0. If it is exactly equal to 0, then it's a leap year. So I will paste it here. So in this one, I have to remove not and I should say it's a leap year. If it is not divisible by 400, then it is not a leap year. Yes. See, if once again I will tell you, if the number is divisible by year is divisible by 4, then it is a leap year. Then there are more conditions we have to check. So in every 100th year, we will skip 1 year. We will not take it as a leap year because we have to do that correction. It's not exactly 2.5, we are taking it as 2.5. So for correcting that one, in every 100th year, means divisible by 100, we will not take it as a leap year. But if it is every 400 year, then we will consider it. Reason is, the decimal was 365.24, then 21. So this, we will cover it up in every 400 years. We will skip, in every 100 year, we will skip 1 year. So in 400 year, we will cover up with this one. So that's it. This is the program. Let us run the program. Year is 1700, not a leap year. If the year is 2000, then it's a leap year. So that's it. So you can check the rest of the years. So hope you have done this program. If you have not done it, then copy it. So try to do the same program by yourself. That's all in this video. We will look for other challenges in the next video.